Hey guys, this video is for those of you who want to learn Node.js. The tutorial instructor is Alexandru Ilies. He's been working in this field for about 5 years. I'm gonna leave his contact information in the description. This tutorial is gonna have two parts. The first part is gonna be the environment setup, and the second part is gonna be the CRUD operations. He's gonna get detailed when it comes to these technologies, for example, Docker, MongoDB, Node.js, how to install. In the first part is going to be how to install, configuration, and stuff like that. And it's a vast tutorial, so if you're just starting up and you don't know much about how Node.js works, MongoDB, Docker, this is the right tutorial for you. If you like the video, please give it a thumbs up, subscribe for this channel. If you have any questions, leave them in the comments. Let us know what you think about this video. And there's gonna be a separate playlist for Alexandru on my channel, so we'll see if he's gonna have time to make more tutorials like this. I'm gonna publish them on his playlist, so you can find it on under my playlist tab. It's gonna have the playlist name is gonna have his name. So that being said, if you enjoy drinking coffee while coding, make sure you have your coffee ready. And let's go ahead and get started.
Hello, my name is Alex, and today we'll start a new series of tutorials regarding different applications and different technologies. And the very first one will be regarding this stack, the Docker plus Node.js plus MongoDB. And we will dive in on what is Docker and how to install it, what is MongoDB and how to configure it, and also we'll talk about what's Node.js and how to install it, and also configuring MongoDB to be consumed by Node.js application, and just an example of the CRUD operation on some entities. And we will split this series in two tutorials. So the first one will be regarding these subtasks, let's say, installing Docker, MongoDB, and Node.js, and talk about them. And then in part two, we'll configure MongoDB in order to be consumed by Node.js application and perform some CRUD operations. That's it. Let's start with the part one then. Good. Let's start with the Docker. What is Docker and how to install it? Actually, it's not so easy to explain what Docker is if you don't have any experience with the operating systems and how the applications were deployed before Docker and how they are deployed. But I will try my best to explain. So if you don't understand something, feel free to wrap up all the Docker documentation here on the docker.com sites, because they have a really nice starting point tutorials and so on. So what's Docker? I thought that the best way to explain it is to use the first definition of the Wikipedia, which says that Docker is a set of platform as a service products that uses operating system level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software, libraries, and configuration files. They can communicate with each other through well-defined channels. Okay. So, let's see what this containers means and also the US level virtualization. And we have here another image which explains very well, I think. So here we have two approaches used for development, deployment, and the lifecycle management of the applications. We have the first one using virtual machines, and the second one uses Docker with Docker containers. The first one is a little bit old, so it's not used anymore in these days. at the scale it was used, but it is still used because of the enterprise applications. And the second one is used more and more. And if you don't use Docker until now for your application lifecycle, then you should definitely try. So how it was done with virtual machine? Let's assume that you have on your local machine you have an application written. Actually, it doesn't matter on which language it was written, and you want to deploy it to some server or some cloud in order to be accessible by world and to be scalable and so on. So before Docker, you had to choose some cloud provider, or you have to rent some servers, or server in this case, because we need only one. So you rented a server, and then you hosted some operating system on it. The host operating system, it means that you installed some Windows or Linux in most cases. And then perhaps for the first step you can deploy already your application from your local machine to this host operating system on the server, right? So you could configure your host operating system to use all the dependencies and to install all the dependencies which your application uses, and configure it and so on, and deploy your application here on your host, install some whatever, if you're using some web application, some Apaches or stuff like that, then it will work, right? But what happens when you have to deploy another application, like second one? You have also to configure your host operation system to be able to install your dependencies for the second application, your configurations, and so on. And that's also good. Perhaps for two applications, you could configure your host operating systems to manage them. But what happens if the third one comes, and so on until tens and hundreds? But let's assume for tens applications. It's more realistically, right? Then your host operating system will have a lot of configurations, and there will be problems with dependencies, with scaling, with everything. And what is the solution for this? And actually, one example, for example, you have two applications, and both of them are using different Java SDK, if you're familiar with Java. I mean, one of them uses Java SDK 1.5, and the second one uses Java SDK 12. So you have to configure somehow your host operating system to use both SDKs, and that's kind of impossible. So what's the solution for these issues? So you have to use the hypervisor. What's the hypervisor of type 2? The type 2 means that is the operating system virtualization hypervisor. So it emulates your hardware or real hardware components, and virtualize your host operating systems, and then you could have here on hypervisor multiple virtual machine configured and deployed. Actually, what is a hypervisor? If you have some experience, for example, you for sure know about virtual box. It's an hypervisor from Oracle. You could try it, it's free. You could install on your Windows machine or on your Linux, on your Mac, it doesn't matter. You can play around and configure some virtual machines. And also another one is the Vmware Workstation, an enterprise one. I think it's not free. And this is the hypervisor layer here. So you've installed this software, and then you configure your virtual machines, like with the guest operating system, because a virtual machine is like a real machine, but it's virtualized, right? But you still have to configure your operating system here. You have to install it. You have to install the updates, the dependencies, and also your app. And your app will be ready to be accessed by world, right? Then the second app also should be configured exactly like you do for the first one, and so on. So you will have here multiple applications isolated from each other. So here you can have a Java application with the SDK 1.5, and here you can have a Java application with SDK 12, and if you see here, it wraps the binaries and the libraries and the dependencies and isolates from each other. So only on this virtual machine you will see the dependencies and configuration for your second application, and so on. And that's fine. That will work very well. And this is how it was done, and still used by enterprise applications. And everything is right now. But then the problem comes with scaling, right? You want to scale your application A, so you can scale only vertically. Horizontally, you should create another virtual machine, another virtual or another guest operating system to be configured, or you can copy it from, because it's simple to copy, but then you have somehow to manage them to communicate with each others. And that's kind of a lot of work, and that's not so easy to do. So for example, if you have here the Windows machines, so your app uses Windows operating systems, then you have to buy licenses for each operating system, or for each virtualized operating systems, and that's a lot of money. And the Docker solves somehow this problem. For the Docker stuff and containerization stuff, you still need the server, because without server you cannot host anything. You still need the host operating system, and you install the Docker engine on this host operating system. So Docker engine replaces hypervisor, but then you configure containers here, and those containers are each one isolated from each another, and share the same physical power of the server, let's say. And then each of the containers is configured to serve and host a specific application with specific configuration and dependencies, and a specific environment, specific operating system here. It doesn't matter which host operating system you have here. You could have a different one in each of the container. And that's a powerful way to develop stuff, and to manage application lifecycle. And just imagine you can configure this container on your local machine. You specify which environment it should use, you specify which dependencies, and then you kind of ship this container to whatever cloud provider you want. So you just take the container from your local machine and then put them on a different machine, and you start the Docker engine, and you start the container, and the application will work exactly like it was working on your machine. So without any need to configure another dependencies or another operating system, and so on. And now we will see how to install the Docker on our local machine. So for that, let's proceed to Docker homepage and see how we can get started with Docker. So if you press the Get Started button, you will be redirected to this page. And for me, for example, I need Docker Desktop for Mac. Perhaps you will need Docker Desktop for Windows. Feel free to try it and follow the tutorial, and you will be fine. They are the same steps. So I will need the macOS edition, and I will download it right now. So let's see what we have here. I will replace it because I already have installed Docker, but I have an old version. So if you follow all the descriptions here, you will be just fine, right? It says that double click on Docker DMG file and then run the installation, and then your Docker will be in the taskbar here. And right now I have Docker desktop is running, right? They say open a command line terminal and try out some Docker commands. Good. I will open my iterm and let's try to have this command. So I have the Docker version. It's for 11 of March, the build, and it looks fine. And if we run the hello world one, what it tries to do, it will search for the image locally, and it says that there is no image locally, and then it will pull from the Docker hub or the public Docker hub the image with hello world, and then it downloaded it and it tries to start it, right? Hello world from Docker. This message shows that your installation appears to be working correctly. So if you get this message, then everything is fine. Or if you want to understand exactly what Docker did behind this process, then feel free to go to dockercurriculum.com, and here you'll find an official documentation, an official getting started point regarding Docker and how to use the Docker terminology, how to use and understand this process, for example, for Hello World application, how it works and what it does in the back. And yeah, it's very important, and please feel free to go through this. Okay, then let's see what we have done. So actually we've installed the Docker and we already proceed to the MongoDB configuration, right? And for that, if you press and search for MongoDB Docker on Google, it will go to Docker Hub, and you will see here some, not some, but an image, a Docker image with MongoDB 1 configured. And let's see how we can run it and what exactly is MongoDB. So the MongoDB is a free and open source cross-platform document-oriented database program, classified as NoSQL database program. MongoDB uses JSON-like documents with schemata. And that's it. What we need to know here. So we have these new terms, the NoSQL and document-oriented database. Basically, we have two types of databases, SQLs and NoSQLs. And yeah, NoSQLs, why NoSQLs and so on, you can search for it on NoSQL or how NoSQL was invented. And here is a brief history how it was invented, and it's really funny, you have to read it. So we have NoSQL versus SQL. So let's have here a brief introductions on what the Mongo team says about it. So the first difference is the data models and schema. On relation databases, on the SQL databases, the schema should be defined in the beginning of the application development. So you have to have a specific schema. You have to know your entities, and after that you can proceed to develop the application. And if your schema should be changed in the future, it's a little bit hard to modify all the schema and the data on SQL databases. But NoSQL, it uses dynamic schema, so you don't have to specify the schema at the beginning, and it allows you to use what's known as unstructured data. So you can modify your schema on the fly. You will just save some JSONs in the database, and it will look at your JSON and save it exactly like it is. So that's the main difference. Yeah, as I said, the data structure. So the relation database uses table-based structure, and NoSQL uses key value pairs, graphs, and so on, like JSON definition. Um, Also the scaling. So the SQL databases can be scaled only vertically because horizontally they are much harder to scale. But NoSQLs you can scale also vertically and horizontally, and that's kind of it. Yeah, you have to understand there is no winner from these two. So SQL and NoSQL, they are used both at the same scale. So um, you have to think about your model or your application, what it does, and if your data is structured, then you perhaps should go with the SQL database. But if your data isn't known at the beginning, then it's better to use an NoSQL, and you will be perfectly fit with all the technologies and all the approaches NoSQL is offered to you. And that's kind of it for the short introduction. Let's go forward and proceed to installing. So if you go back to our Docker Hub page on our Mongo image, Mongo Docker image definition, you will find here and how to start or how to use this image. And we have here a command. We just have to run this command in our terminal, but first of all I will show you something. So in the Docker help, if you follow the Docker curriculum or you have some experience with Docker, and you will need some commands here in order to work with Docker. So we have one which is images. It just lists the Docker images which are ready and downloaded locally, right? And if you press Docker images, you will see that I have here some already downloaded images from the past. We will not use these images here, but they are here. And you have the tag, the image ID, and created that, and the size of the image. And if you look at them, we don't have any MongoDB image here, right? And let's try to add some Docker DB image. If you press this command here, you will receive an error because the tag, actually, if you see here, is the version of the image. So we have to specify some tag. And let's use the latest. It will download the latest version of the Mongo. It will look for locally, and it will say that there is no image locally, and it will extract and download all the images and containers, or in this case the images from Docker Hub. Good, and it downloads our Docker Mongo image. And now if we use Docker images command, we should have here add Mongo image, and that's it. Also, we specified the run command. What does it mean? When you specify Docker run, it starts a container or a container from this image. Actually, if you go and press Docker PS, and Docker PS is the command for list of the containers. So we first listed the images, and now we list the containers. And if we go and says docker ps, it already started our Docker image with Mongo, and it already runs on port 27017. I have here another Docker container which is started 58 minutes when I started the Docker, I think, but we can stop it. So I will just press docker stop and container ID. It's enough to press only the 2 digits here, the first two, and we will have only MongoDB running on 27.0.0.17 port. And actually, what this MongoDB image contains in the behind this Docker image, you can see at Docker MongoDB image GitHub, because it's open sourced. And here you can see exactly what the Docker file looks like. So the Docker file is the configuration file of the Docker image. So when the Docker image is built, then this Docker file is used, and actually these are all the configurations which starts the MongoDB and installs the MongoDB. And if you see here, we have here from Ubuntu Bionic. Of course, this syntax is not familiar for you if you don't have any experience with Docker, but please feel free to to follow some tutorials, and you will understand exactly what happens here. But yeah, actually, this MongoDB image is backed by Ubuntu operating system, and then there's some commands here which download all the source code, I think, and configure it and then run it. And in order to see exactly how this container was made, we can go and inspect this container, right? Because this container right now runs on Ubuntu, right? We are on macOS here, but this one runs on Ubuntu, and we can investigate and inspect this container to see exactly what does it contains. And Docker has some command for it. Docker exec minus interactively, and for fee, the container ID, first digits, and then I think bin bash, because on Ubuntu you use bash. And here, if you see, we are inside the container, so we are not anymore in our macOS, or we are not in the host operating system. If you remember the image from the beginning, we are in the Docker containers operating system, right? So we've done this without installing any Ubuntu and anything else. We are inside the MongoDB containers, which is specified by this Docker file. And here are the configuration made by MongoDB teams. And if you have enough experience, you can go through it and see what they did and see what they configured here and so on. We don't need this right now, so we will exit the container. Right now we are back on our operating system. So far so good, but let's try some MongoDB queries in order to see exactly that it works as expected and everything is configured as expected. So first of all, I will go inside the Docker container with Mongo, running command docker exec interactively, and the container ID, and path for our bash. So here we are inside the Docker container, and if we press Mongo, then we are inside the Mongo application. And right now we can execute some commands. On the documentation of MongoDB sites, you can find some CRUD operations and how the general query looks like. So we have here for insert one, we have the database name, the collection, and .insert one. And you just pass an object here, like a JavaScript object, and it will create this object. Good, then let's try a little bit. So let's try this command. First of all, we want to be sure which database we are using, right? And for now, we can write the command show DBs, show databases, and we have three here: the admin one, the config one, and the local one. So let's use local one. Good, and now we need our collection. So if we press show collection, we have only one collection here, the startup log. Let's create one. Create. So the command is db.create collection, and the name of the collection, which will be in this case users, right? We have a return here, which is okay. And if we press the show collection again, collections, we have our collection created here, which right now is empty. So let's try to insert an object here. So the database name local, the collection name users, insert one, and let's pass here the JavaScript object name. Let's say Alex, and age, let's say 26. It's enough for now. Local is not defined. Okay, because we are inside our local database, right? So we just press database, and we got here a return acknowledged true and inserted ID, the new object which was created. It got an object ID from MongoDB, which is unique in this case, right? We've inserted some data in our users collection. So let's find some data in these collections, right? And for that one, we can try to press this just find command, and it will return our object, which has the ID or the object ID which was assigned to it, and the object itself, right? If we go back and insert another name here, John. Okay, the local is not defined. I got you. It's the DB one. And if we go and find it, the users collections right now contains two objects, right? So everything's working as expected. Let's go forward then. So let's check also this, this task as done. And we are dealing with the last one. What is and how to install Node.js. So Node.js, if you will go to the Node.js official site, you will see here some very interesting phrase. So Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. What does it mean? So what's the difference first between Node.js and JavaScript? Because the code, let's say, looks the same, right? So JavaScript is a programming language which runs only on browsers. So in every browsers, you know, like Chrome, Firefox, and so on, they have installed or configured inside the browsers an interpreter or a JavaScript interpreter, which interprets your JavaScript scripts in this case, or code, and run them. And as I said, the JavaScript runs only on browsers, not outside browsers, right? But then we have Node.js, which can run outside browsers, like on your operating systems, right? Without browsers, without anything. So how it was done? First of all, you have to know that the Node.js is an open source programming language, and the source code can be found at GitHub. So the whole implementation of the Node.js programming language is here. So if you want, you can go to the documentation and read every steps and every code, and you will be a Node.js expert. But then, again, how it was done? We have here the syntax that is built on Chrome's V8 JavaScript engine, right? Let's see what's this. The V8 is a Google open source high-performance JavaScript and WebAssembly engine written in C++. It is used in Chrome and in Node.js, among others. Right, what does it mean? So the Chrome engine uses this V8 implementation behind browsers or inside browsers or inside Chrome browser, which is written in C++, right? Because it is written in C++, you know that C++ runs on at operating system level, so you can somehow call the C++ APIs from JavaScript, and this is what they done. They've implemented some JavaScript interpreter in order to call the C++ APIs in this case, or engine APIs. So it's all the implementation, like the low-level input outputs of the operating systems, the low-level commands like working with files, working with processes, working with different permissions or operating system permissions are written here in this engine, which is in C++, and then from the JavaScript itself, you just call those APIs. So the engine isn't written in JavaScript because JavaScript runs only on the web browsers. You need an interpreter and so on. So it's like, let's say the Node.js, it's like a wrapper for this engine, okay? And because it's a wrapper, then you can write Node.js everywhere, and it will call those C++ APIs, which are the APIs written in this engine, and then you will receive events or send events to the operating system and back. So this engine, let's say it supports Windows 7, later macOS, Linux, ARM processor, MIPS processors, and so on. So it supports everything. And because it supports everything, then you can use Node.js everywhere. Let's say on Windows machines, on macOS, on Linux, on mobile devices, on MIPS processor, and so on. This is let's say the high level of the definition of the Node.js. So let's talk a little bit about also the motivation of writing this Node.js programming language. So as you know, in the past, there were a big difference between backend and UI development. So there were a lot of guys who knew um, the UI development, and they knew JavaScript and HTML and CSS, and they kind of didn't want to put their hands on the backend stuff, because you have to learn a new language, programming language, you have to manipulate this language and so on, and that's kind of let's say a problem for the beginning. And because there were a lot of UI developers who knew very well JavaScript, and there still are a lot of UI developers who know JavaScript, the motivation was to somehow migrate the JavaScript to the backend stuff in order to be easier to learn also the backend stuff and to manipulate the backend stuff. And yeah, they kind of succeed regarding this approach, because they migrated, or they invented the Node.js, which is exactly like JavaScript, and now the UI developers somehow understand what is in backend if the backend is written in Node.js, right? And it's easier to solve problems and solve bugs and so on. And yeah, this was the motivation, to have one language everywhere. And they kind of succeed, as I said. I'm not sure it is good or bad, but it is like it is, and JavaScript is dominated programming language. If you take a look at the annual report from Stack Overflow, and it seems that it works. That's kind of it. So let's go back and try to install it. Let's install this LTS. The LTS means long-term support, and the current version is the latest one, which has more bugs and so on. We are good with the LTS and the version 12. Here we are. Yes, we agree with all. Let's see the installation. Okay. Install it. Good. Let's try it. We go on our terminal and write here node. We will receive the node command, but I use the version 13.10.1. This is because I've already installed it in the past using NVM. Now NVM is not version manager. We will get a little bit later to this, I think. And actually what it does, it allows you to switch between different node version without any manual installing and so on. So right now, let's say use the same version as in the site, the long-term support. So the version number 12, 16, and 1, right? Okay, it found it, and it tries to download, and now we are using the version 12, 16, and 1. And let's write some commands here, right? Log hello world. here we are. So the Node.js is configured in our host system. Let's go then forward, and forward will be the part number 2, which is this one. So we will go through connecting MongoDB to Node.js application and perform the CRUD operations from Node.js application, right? So see you in the next video.